handle 8,000 bits a second. Eric, you ready? Without further ado, everybody who is talking now stop, find your seats, and give your attention to Eric, please.
Thank you, good night. I got the applause already. Okay, well, hey everybody, I'm Eric Falcao. I'm one of the founders of Mass Relevance, and we're a startup that came out of this group, bootstrapped a few years ago, and now funded by Austin Ventures and Floodgate Ventures. And day to day, I'm the director of platform. I focus on scalability, high availability, keeping our servers up, and serving traffic as fast as we can for all our customers. And a couple months ago, we did an event with the White House and Twitter called the Twitter Town Hall. And I had tweeted that we were doing 8,000 requests per second on our Rails stack. And so Keith reached out to me and said, hey, how did you guys do that? Would you mind talking to us on Rails? So it turns out that this talk is basically about Varnish. And so what's the problem here? Rails is a great web framework. This is what binds us as a community. This is what brings us all out here tonight. We're able to ship code faster with Rails. It's built on a language that we all love. And it's awesome, but I have come to learn that it's not specifically very strong at maximizing request throughput. And I would say nor should it. That's not necessarily its strong point. When you kind of look at your typical Rails deployment today, you have Apache, Nginx, and some amount of Rails processes behind it. And having 16 Rails processes per server is just not going to saturate your network connection. And that's what I was trying to achieve. And how did I achieve it? Well, Varnish to the rescue. And Varnish is an HTTP accelerator, which is to say it is a reverse proxy with caching. And one reverse proxy that we probably deal with a lot is Nginx, where you say, okay, Nginx, here are all my Rails servers, load balance among them, remove unhealthy servers, and help distribute my traffic. And Varnish is a lot like that. It's very similar, except it has a caching layer that is very fast. And how did I choose Varnish? I mean, it's got all the checkboxes that matter when we chose Rails. It's open source. It's born in Denmark, and the author goes by a 3-letter acronym. So, I mean, need I say more? It meets all the requirements. So I'm going to talk a little bit about PHK, as he's titled. And this guy was a FreeBSD core team developer for 6 years. He did one commit every 18 hours in his heyday. He implemented malloc. Okay, so this guy's hardcore. One of the versions of malloc. You may have heard of bike shedding. He brought that to the internet, that meme to the internet in 1999. And he was paid to write Varnish by a Dutch tabloid, and he wasn't really interested in the project, but he needed the money, and he said, I'd like to, get out of kernel development and show, what it takes to write a good userland program, so outside of the kernel. And I guess my point here is that this guy is a badass, right? I mean, he is a great developer. He understands systems engineering at its core, and he wrote Varnish. And so I'm going to go into some of the highlights here. First and foremost, Varnish is programmed in a modern way of thinking about operating systems. And what that kind of boils down to is respect for virtual memory and understanding that, as developers, we're kind of coached that disk is slow, RAM is fast. This is true, but the key here is that operating systems aggressively cache disk and RAM when you use it. So, to look at another open source project, Squid, which is a lot like Varnish, you configure, okay, how many, I want to hold, 400 megs in RAM, but if it doesn't fit in RAM, I'm going to go to disk and pull it out and store it in RAM. But what this is actually doing is it's working against the operating system. Varnish doesn't do that. It just says, look, there's virtual memory and everything will be handled by the operating system. I'm not going to work against it. And everything he's paid a lot of attention to every single system call that it takes to do a request. It's configured in a DSL that compiles down to C, very fast. The configuration can be hot swapped on a running server. And what's nice about it is I believe that it's very easy to drop it into your Rails stack very easily, mainly because it respects your headers by default. So what I'm saying is you can put it in front of your Rails stack today and it probably won't break anything. I mean, definitely test that out. But I guess what I'm saying is you can put it in front and give it a try and then slowly start to cache things with Varnish and let it start working for you. And it also has a very interesting feature which I'm going to demo called edge side includes. And this is something that came out of Akamai many years ago. And the idea behind edge side includes is Varnish can go grab a page, and when it comes back to Varnish, if there's a certain tag in there, and the tag looks a lot like linking to a style sheet or whatever, it's an include tag, and it'll say, go pull this other piece of content too, and it'll do that in the back end, and then inline that and spit out one page. The point being that you can have a page that's consisted of many parts and have each of those parts individually cached in different ways. So I'm going to do a quick little demo here. I don't know how I'm going to do it with the mic, but let's see how it goes. Okay, so right here, this is kind of the most vanilla Hello World Varnish configuration file. I basically say, here's my backend. It's my local Rails server running on port 3000. Does that need to be bigger? Okay. It's running on port 3000. And I have another little configuration here called Grace. And this is another Varnish nicety. And Grace is basically saying, okay, a request, I have 1,000 requests per second coming in for some page. Let's say that page is expired in my cache. It'll actually serve that expired version and then asynchronously go and pull a fresh version and then serve that as the new version as soon as it's available. So this is just a way that, once again, you can do maximum throughput and have Varnish kind of do a lot of work for you and not have it wait on your backends. So right here I have my Rails app running. Down here I have Varnish stat. Where my cursor is right here, that's how many requests per second Varnish is handling right now. And I have a little Rails app that I call Places. And what I've done in the controller is I've done a before filter called set cache header. And all that does is set a cache control header. This is all. One nice thing is that it's always just using basically HTTP headers. It respects the HTTP protocol. And I say, okay, this page is public and it has a cache life of 5 seconds. So right now I'm hitting this page as fast as possible. You saw that Rails got 1 request. You see down here Varnish is doing 30 requests per second, and you see every so often that there will be a request coming into Rails every 5 seconds. So this is like what I consider to be the levy at Mass Relevance. This is how I sleep well at night, knowing that we have something very, very similar to this, which is every public page is cached for a minimum of 5 seconds. So I know that any request will not be hit, any page will not be rendered more than once every 5 seconds. So if I'm getting hit 5,000 times a second, that's 25,000 requests condensed into one. And that helps a lot. And that's pretty easy to get going. So my next demo shows off what ESI is. So here I have a detail page for Strange Brew Coffee, and it consists of a header with an address and some comments. And what I've done is, and this is a little bit unnatural, but it was kind of the easiest way to facilitate the demo, is I'm using Rails respond to blocks to be able to render the header and the comment independently. And I'll show that right here. If I add place1.header, it just renders the top. And if I do place1.comments, it just renders the comments. And let me show you the main show view. So what I have here is 2 ESI tags, and what it's doing is saying, okay, the source URL for the header is my URL, and merge in the format of header, and then include a timestamp of when the header was last updated. And I do the same for the comments. Params.merge format comments. When was the header? When were the comments last updated? So when I do a request for this page, you see that I just got 1 request to Rails. If I hit that as fast as possible, Varnish is only getting a request every 5 seconds. Now, but what I want to do is I want to change the address. And I've put a delay in on purpose here too. So when I refresh the page, because the last updated timestamp has moved forward in time, there's a delay, and it renders the whole page. But what you'll see here is that it hit the main page and then also rendered the show to header, which is just the top piece of the page. So what I've done is I've cached 2 pieces of the page independently, and when I return the header, because it's slow to render, let's say, I've set the max age to be a year. So in effect, it never expires unless that timestamp moves forward. And I guess an important point here that I haven't mentioned is that Varnish caches based on URLs. So when I change any URL and move a timestamp forward, it acts as a cache buster. So I guess I'll break for questions here, because I hope I've conveyed this pretty well, but yes. Okay, so the question was that there was a delay there. The delay is intentional. I actually put a sleep here, so when I'm rendering the header, I was trying to illustrate that when there is a cache miss, I'm simulating that it is slow to go and render that data. So I'll do it with the comments too. So I'm going to add a comment that it's open 24 hours, or wow. And I guess what I'm illustrating here is that by using creative cache invalidation, it's easy to have pages that only update when they need to. So right there, I refreshed, my open 24 hours content comment is now available, and you'll see in the log that here I rendered show for comments, which is just the comments portion of the page. That's the only thing that had to get rendered on that request. And now that my caches have all been warm, I can hit this page as much as possible. It's doing 30 requests a second right now just by me refreshing. And what's neat here is that all that's getting checked is when were the things last updated? When was the timestamp? You know, when were header and comments last updated? So here I'm fetching only the timestamps that they were updated. Any more questions? Yes.
How are you testing the high traffic? Is it a browser plugin, or is there another tool that you can use to like really hit your test server as fast as possible?
So the question is like, how do you test this to make sure that you're bearing the right load? And the answer is that it's really freaking complicated, because there is Apache Bench, which is AB. The tool is called AB, and you can simulate hitting a URL very fast. That is very nice, but it's just not a good substitute for real traffic. So what we've done is when we have an event, like we did this for E3, we have, let's say, 3 front-end servers. We'll start taking them out of load balancer to try to like see how much one server can handle as kind of a test. And of course, we're always ready to throw it back in if we saw any more problems. So like that's to me like the only true metric is that we were able to handle 3,000 requests per second on one server during E3. You know, with Apache Bench, it may show 10,000 or 12,000 requests per second, but I just don't trust that number as much as real-world internet traffic.
How are you doing it right now?
Oh, well, right now I'm just hitting a refresh as fast as possible. It does it about 30 times a second, apparently. Yes?
Would you use this in conjunction with, or does this replace something like Memcache or other caching?
Okay, so the question was, would you use this in conjunction with Memcache? Yeah, I mean, we don't use Memcache. If that helps answer your question. To me, it's like, this is enough of a caching layer that like, I don't touch rack cache, I don't touch Memcache. And Memcache was an option for us, but you know, we're deployed in EC2, and one thing that kind of bugs me about Memcache is that you have to keep a list of servers around, right? Like where are my Memcache servers? And to me, on EC2, servers can come and go so often that I'd rather not deal with that management. This felt a lot easier.
Does it minify output or anything like that?
The question was, does it minify output? The answer is no, but in the latest version of Varnish, it'll actually, when it requests a page for the backend, it'll store it both gzipped and not, and then serve it based on whether or not the browser accepts it. So that's pretty cool. That's a brand new feature. We're not even running that version of Varnish yet in production, so I can't say more about it other than yes, it kind of does something like that. Okay, so that, I'll have more questions at the end, but that sort of is just a little demo of like what it takes to kind of drop it in, etc. Yes?
How many writes per second were you taking?
So the write path is not a path that we optimize for. Let me rephrase that. Our app does thousands of writes per minute, but it's not in the front end. So I'll talk about kind of what we do as a business next. So Mass Relevance, what our business does is we connect to, let's say, the Twitter streaming API, we connect to Facebook, and we pull down content in real time that's happening about events, and we analyze that data, like pull out profanity or reject spammy content, and then we deliver those to new streams that are relevant for our customers. So just during the town hall, we were filtering questions to the president, and then there's a curation layer there. So yes, there are a lot of writes. On average, we do 6,000 analyses per minute, but they don't happen in the web request. They happen behind the scenes because they're streaming in from Twitter. So this is kind of like what our app does. But in general, Varnish is not necessarily that great for write traffic because it kind of has nothing to do with write traffic. It'll pass it through to your backend. So you're still going to have to make that fast, but that just, is not our problem. So in my life, the road to scale is paved with fail, but at least these are kind of good problems. Like, it's okay in a way that, we'll sign a new customer and they will slam our servers and we'll hit a new high. And yes, we'll have to tweak our configuration or something or optimize things a little better, but at least we're, hitting a new high watermark every time. And so this is our outbound transfer in gigabytes, so it's about 7 terabytes or 8 terabytes a month now. We first put Varnish in actually to the left of that graph. So one day we had signed a big media company and they integrated us into a little Android widget, and that just overnight was hitting us 200 requests per second. And yes, I could have added servers, but it just didn't feel right. It didn't feel like I needed to add a server. I felt like it should be doing more for us, and so that's where Varnish came into play. So I basically rolled in Varnish in a couple hours, got it alive, and we were good. We were handling 200 requests per second, no problem, on one server. This is great. And then we just kind of had it going for a month or so. The second problem, the first main problem with Varnish happened 3 months or 4 months later when we were doing about 400 requests a second per server. And I don't know, who's been bit by this? Number of open file descriptors. Yeah, this is like, when you're starting to see a server actually handle a lot of connections, Ubuntu by default only allows 1024 open file descriptors out of the box. And in Unix land, a file descriptor is also a network connection. So effectively, you cannot have more than 1024 connections open at any given time out of the box on Ubuntu. So if I can just sum this all up, you need to up that number. So on all our servers, in our chef scripts, we increment, that's set to 300,000. And so that solved a whole class of problem for us. And then our app was able to basically push as much as we threw at it. Okay, so our second major problem with our caching layer has to do with JSONP. And I'm going to give just a quick primer on what's going on here. So this is a request for content off of our server. And what's going on here is if a JavaScript client is requesting JSON from a server, you can pass a callback, and so that's the function that gets called back when the data is returned to the browser. And jQuery, by default, uses a sort of timestamp-based randomized function. And the way it works is it passes that function to the server, and then the server spits out the function name, left parentheses, and then the content, right parentheses. And so when that content gets shipped back to the browser, it's just evaluated and run as a callback function. Now what sucks about this is that that callback function, if that wasn't there, this would be a perfectly cacheable bit of content, right? I can use my 5-second cache happily because I wouldn't have to spit out the content in red. But because that's the way jQuery works, and because we can't control the way that our customers integrate with our platform, we need to handle this case, which is that every function that's being called, every request that's being made has a unique callback function. And this has hurt us before, where we're doing the Nickelodeon Kids' Choice Awards, and our servers are getting hammered. Why? Well, I look in the logs, and every single URL is different. Well, because Varnish caches based on URLs, we were having a cache miss every time. And so what we did is, I just booted up a ton more servers, and we were fine for that night, but it bothered me that we weren't able to just serve this within our Varnish framework. So what we did is, and so Varnish has a very advanced configuration language. You can mangle requests, you can remove cookies, set cookies, add parameters, remove parameters. It's crazy. So what we do is, when we see that there's a callback parameter, we strip out that function and we stuff it in a header. And then we take what's left of that URL, the good URL without the callback function, and stuff that in another header. And what we do is we pass that to a separate server that just knows how to emit function name, left parentheses, ESI include tag, so the raw content that's good and cacheable, and then a right parentheses. And so what you see here is the only C code I've ever written in production that can do 30,000 requests per second and has never crashed on me and only uses 1 meg resident memory. So I'm very proud of this, but all it does is say, okay, I have a callback parameter header, and I have a URL that I'm trying to get to, and so spit it out just the way it needs to go. And I guess what, if you can imagine for a second, it's foo 1, 2, 3, 4, 5, left paren, and then an ESI include tag for tweetriver.com v8 kindle.json limit 1 is what the inner call is, and that is cached. So this is good. This got us to our happy place, which is where we were powering this Barack Obama Twitter town hall. We are powering all the tweets you see on that page. And those widgets were polling our servers roughly once every, I think, between 5 and 10 seconds. And so when he was being asked a question on Twitter, that question at the top right would flip out on everybody's computers around the world. And so we were getting hit, 8,000 requests per second by them constantly checking and pulling and pulling new content, etc. So this is where this is the happy ending, right? Well, today there was an earthquake in New York, and our Varnish config had an issue. So I'll kind of explain what happened there as sort of an addendum to like just when you think you have it figured out, you don't. So Varnish tip. What basically happened was one of our customers put a space after JSON. So it's like, go pull this stream.json space question mark. So Rails was saying, do I know how to render the format JSON %20? Which it doesn't. It doesn't know how to render that request format. So it was throwing a 406 not acceptable or whatever it is. It doesn't know how to render JSON %20. So Varnish doesn't cache errors. It only caches happy path stuff by default. And so what we were having was we had all these thousands of browsers hitting our site with a bad URL, and Rails was returning a 406 error. So here's your Varnish pro tip. You got to cache non-200 responses. And so the second we did that, we were good again. And it just goes to show that our Varnish config is pretty awesome. 90% of the time, it works every time. So that's how that went. So that was humbling today, right? I mean, that was definitely humbling to kind of have an issue the day that I speak to all you kind folks. I have a couple resources up here. Obviously, this is useless right now, but when I upload the slides, they will help. And I would like to take any questions. Yes? Is the JSONP code available somewhere? No, but I should release it because I figure that this is probably something that most Varnish users who provide an API would be interested in. It's surprisingly not something that's core to Varnish, but I guess I'm pretty bad at open sourcing code, but I'll try and work on that. Yes?
Is there anywhere, if you're just getting started, like anywhere that has like example Varnish config files or something? You know what I mean?
Yeah, so there are example Varnish config files. I would steer clear of them because they're like every single thing you can do with Varnish. They're like 1,000 lines long, and it's like, here's how you can do magical Google Analytics cookie stripping and block requests from certain domains, etc. So they're very powerful for understanding what you can do with the configuration language. But I would say that the best thing you can do to start is just start a Varnish server and say, this is my backend, and the backend be your normal Rails process. And how we got this out in production was I installed Varnish out on our production servers and had it running on port 81 to start. So I had it running on port 81, and I had our Rails app running, Apache running on port 80. And that was a nice opportunity to sort of hit Varnish and have it out there in production and test it without sort of mucking with what's running in production. And then when it came time to make it live, I flipped it. So I have Apache running on port 81 and Varnish running on port 80. Anybody else? Yes?
It seems that caching your content for 5 seconds would have other users see the same content.
Yeah. So caching, the question is, it would seem like caching content for 5 seconds would have other users seeing the content. I think the important point, if I understand your question correctly, is that this is publicly available content. So the content at a URL is something that everybody, all the users in the world would see. So it's not like this is, Eric's private content that's being cached for 5 seconds, or Brian's private content that's being cached for 5 seconds. This is kind of like a canonical piece of data that it's okay to cache it for 5 seconds. Now, yes, even though we are a real-time app, and in theory we're always serving the freshest data, I'm okay with condensing thousands of requests down to one if it makes sense. And I think this is a good fit for us, yes.
Have you tried comparison versus, I don't know, just using Apache with a static HTML file?
Apache with a static HTML file. Yeah. Okay. So, no, because our content is changing every second. I mean, I don't really want to be spitting out a bunch of static files all the time, because as soon as I'd spit it out, there'd be a new one. I also don't really want to be writing to disk, and then also I've had trouble getting Apache to handle this type of throughput anyway. I mean, I've tried, before I put Varnish in place, I tried to tune Apache, and I just didn't get that far. Yes?
So the default caching mechanism doesn't typically put the partials and stuff in the memory. And can you control, if you have limits on those servers, like what goes in memory and
So the question is, does it typically store the partials? I mean, like when you're saying the header versus the comments example, so those headers and comments represent URLs. So to Varnish, they're just like any other page, right? And they have an age just like any other page. Now, I think the second part of your question is like, how do you control what goes in? I think the answer is you kind of don't care what goes into Varnish's cache. The point being that stuff that doesn't get used will fall off the end.
what I was referring to is like if Varnish is caching some stuff, it's going to hold it in its in-memory structures rather than leaving it out to this, right? Can you control the ratio of what stays within Varnish's memory as opposed to what gets into Varnish's disk?
Yeah, and I think this is what PHK refers to as like 1970s programming, where you think about RAM versus disk and loading things in and out. And I think he's saying, look, I have unlimited virtual memory, and if the memory segments that are in RAM are not being used, they will be paged to disk by Linux. So that's the kind of, you do tell Varnish, hey, don't ever use more than 2 gigs of RAM, but, and then from there, I think, it kind of handles some of the details there.
So you don't really prioritize, if you need to, you don't prioritize.
You don't what?
You don't prioritize.
No, you don't really prioritize. And I think, if I could give another example of this model of like, look, don't worry about RAM versus disk. Cassandra is another project I follow very closely. And they have this idea of a row cache, which you size. You say, okay, my row cache is 3 gigs. And the idea there is when I have a row cache miss, I go pull the data from disk and then stick it in the row cache and serve it back to the client. And they're saying, look, we wrote that, but we really don't think you should use that at all. Like they're saying, having row cache on is a bigger liability than it is a benefit, because it's a lot better to just let the operating system, let Cassandra think it's always going to disk, but in effect, most of the time it's going to file system cache disk. Yes?
I was just curious, during the town hall, how many EC2 instances did you all have going? What size were they?
So how many EC2 instances do we have going? So, I'd love to give a talk about EC2 also, but we had 10 instances going. Each one was doing roughly 800 requests per second. They're C1 XLs. Now, I should add that our default node actually does a lot of things. So I have this kind of theory that if I put services A, B, and C on one box, rather than service A on one box, service B on another box, and service C on another box, that if I make this homogeneous node that does a lot of things, and I have 3 of them, if any 2 of them die, my site is still up. So our default node has Varnish, has Apache, has Rails, runs the JSONP ESI 30-line wrapper code on it locally, and it also does its share to analyze tweets. So the idea is that anytime I'm feeling like the heat is turning up and there's an event coming up, I can just launch just a bunch of those and kind of have my bases covered. Now, is it perfectly optimized? No, because sometimes I may need more tweet processing versus page serving, but in general, it helps kind of raise the bar for an event. I might change that. I change things constantly.
You mentioned having Varnish on your web servers. How CPU instances is Varnish?
how CPU intensive is Varnish? The answer is it's just not. I mean, it's pretty sick. There's benchmarks, and take benchmarks for what they're worth, but 275,000 requests per second with Varnish over a network link, over a gigabit network link, and the CPU is like sitting at like 0.2 or 0.3 or something like that on a Linux machine. Take it for what it's worth, but the point being that it's not really CPU bound. Why? It's because this guy is just hardcore. I mean, he has actually measured that a cache hit uses 13 system calls, and that a system call uses this many clock cycles, and therefore, I can get this one throughput. Anybody else? Okay, I think that's it. Yeah, that's all I got. If there's no more questions, you can come and find me afterward too. Or buy me a beer. I haven't had a beer yet, so thanks guys.